All right, I think that we can start on this session now. The idea was to have a discussion among the people in the audience on what was presented actually in the previous session concerning the facility definition team for material science. Wajira has presented that the recommendation will be to initiate the development of new post-ISS facilities, a containerless solidification facility, a directional solidification facility, and an additive manufacturing facility. And we wanted to kind of sound out the feedback from the scientific community that would be present here today. That is not that many people, to say the least. But of course, if you have any comments to make there, we could do that now. I think I will just hand over the microphone to, let's start with Sonia. Yeah, what your thoughts are on these facilities? Does it make sense? Is it?
Okay. Yes, definitely they make sense. Maybe one question to the facility development team. So what I'm missing is in principle, so the time scale is always a problem. For example, MSL, it took 2 years until from the definition of the experiment until implementation on the ISS. I'm thinking about if you have already installed a facility, you developed it, and then, for example, you process one after another experiment, just changing a little bit the composition. So what I observed is that, for example, just change in MSL the composition by 1 to 8% of some elements. We have to go through all the process in qualification, checking the reaction, etc., and we lose in principle 1 year. And this is a point which I found when you say processing takes a long time or so. From an operational time of view, we would like to do everything that the samples will be processed as soon as they are on board.
Yeah, this is a very good comment, and we see it regularly. Just to remark, we're going through a similar exercise now for the X-ray facility. And then indeed the question comes up, which materials? And so we try to define in possibly wide ranges. So it's aluminium copper with copper between 0 and 100%, like that. Okay, that is the basis. And so indeed, in that point of the development, we would have to define what we want to process as widely as possible. So now we have aluminium, germanium, and then one scientist says, I may want to add a little bit of grain refiner because it helps us to get the grains in a size that we can sensibly see what's going on in the experiment. Okay, then we need to specify what the grain refiner is, and the scientist says, anything that works. So you need to know many things ahead, and then in this particular case, it was also that this turned out to be an experimental grain refiner that the scientists tested and which worked fine. But then there is not a materials safety data sheet for that. And then it becomes difficult already. I have no ready answer on how to solve that issue, but it's certainly one of the things that's keeping up the proceedings, not only in time but also in cost. Because if you have to go a new qualification, it has to be all to be redone. Yeah, good remark. No solution, unfortunately.
Because I have to make one other comment is, for example. You said something about the thermostability of MSL. You are right. It's not so good as it could be, but it's built for many years ago for crystal growth experiments, thinking about processing some samples over weeks in principle. So this is maybe the reason why now, because if you check the long list of experiments which was performed now, most of the experiments took maybe a few hours. And this is a problem why we don't reach this thermostability. So this means if you define now a new facility, so concentrate not only on a single class of experiments, try to check what will bring the future. Yeah, otherwise you have some problems.
Okay, thanks. Shall I go to fun? You get each get your turn.
My comment would be, yeah, so maybe I speak as part of the Tempus team, continuous processing facility would be definitely needed, I would say. And we are interested also, on the one hand, this non-equilibrium solidification, but also the autothermal physical property measurement. I think from our side, actually we have the good aspect that many things can still be tested on a Tempus facility. So maybe if at some point this will be more concrete, we can also get contact that things can be still tested and ideas to validate also on a Tempus.
Is there any specific limitation you encountered in your research in terms of camera resolution?
We were speaking during the break that if you look at my experiment, so it's upcoming. So one of the problem was really fluidity flow, because if we heat up the sample with a coil, so you have still a lot of turbulence in the sample at the beginning. That's why we need to wait quite long until that the sample is really quiescent and everything. We were thinking about whether this can be done by a laser, which does not introduce then so many flow in the, so definitely much less compared to the heating coil of the EML facility. So this would be one idea, especially in my case, that to reduce the flow in a sample.
Thanks.
Yeah, so perhaps commenting on that, so the idea was to make use of the positioning coil and perhaps not use the coil system for heating, but replace that perhaps by a laser. Therefore, you have more flexibility for lower melting point materials. At the same time, I could also see that the advantage if you want to go to higher temperatures, let's say you need perhaps more energy with the coil system, efficiency and so on, it might be difficult with the thermal load. So perhaps that could also be something to reach these higher temperatures just with a laser that heats up the sample. I think still that the EML for conductive samples, I mean, in terms of positioning and so on, is the way to go. Not so much going in the direction of ESL for that particular case. And I mean, in Tempus, a couple of other things have been tried out as well recently. I think there was tests about the stress fields, residual stresses in samples using basically optical fibers, Bragg, what was it called? Fiber Bragg gratings, in order to measure the residual stress during the solidification of the material. And that has been shown in Tempus. So I think Tempus could be a test platform for new technologies, being perhaps ready then for a facility to be built for a LEO platform, whatever it might be.
So the suggestion is to use Tempus as a technology demonstration or validation platform.
And start that exploring ideas already now to be ready when it's clear or it becomes clear what kind of LEO platform would be the one available afterwards.
right, anyone willing to contribute? Anything more? Can I ask the people I actually do not know to comment their background and how and their interest in the discussion? Is that a way to do? If you want to?
Yeah. Okay, I'm in the fluid physics facility definition team. It's not that I'm a spy here. It's just my. It's just that long ago my PhD was on solidification. I was curious about how is the topic nowadays, and it's just that. Okay, but I did only numerical simulation. I never did experiments, so it's just curiosity. So.
Good, thanks. Let me see who's more. Ah, yeah.
Yeah, Hubertus Thomas from Institute Materials Physics in Space. I'm doing plasma physics, so I'm also more interested from a different point of view, especially because our colleagues here from material physics are here, and there's of course the future of the institute.
Yeah.
In material science. So plasma physics and plasma crystal experiment, which is part of ESA Russian project. That's our experiments. And
Yeah,
I'm
yeah.
talking also for
Yeah, it's more or less the same for me. I'm also from DLR Cologne, also a plasma physicist, and yeah, plasma and materials, these are things that often come together. So why not?
All right, and then we have a gentleman here, maybe willing to.
I'm just a reporter.
Oh, you're a reporter. Oh, okay. That would not be okay. Yes, go ahead.
So maybe I wasn't attentive all the time or enough, but it's not very clear to me what are the next steps with the output from the facility definition teams.
We did the facility definition teams for all the different disciplines. For material science, we put them in one, proposing, well, now 3 facilities. There were other ones. I think there were 2 or 3 in fluid physics and so on. That doesn't really matter. What we end up with is the reports from the teams with the, let's say, well, the proposed way forward for post-ISS LEO research. That's a big list. And then the next step will be, of course, depending on the budgets, but for sure we will take as one of the next steps to do dedicated studies into the feasibility of these facilities. Of course, we may have to down select, but the idea is to engage industry in actual studies to develop the facilities and how they should look like. So for instance, from the science perspective, we now propose a next generation EML using all the lessons we learned over the last, well, 2 or 3 decades. Depending on which direction the post-ISS discussion goes, it can be, well, these free flyers or a platform like this, platform like that. Depending on that, you have also different constraints in terms of energy and duration and so on. So the discussion is still open on if it will be an EML with 18 samples we have today, or maybe it's one with 3 samples with shorter duration and a completely different operating scenario. That is still open, but what's defined by the definition teams is the scope of the scientific investigations that can be done. And so one of the things proposed for the EML, the new EML, is to go into higher temperatures to also catch a new category of materials that can be investigated with that. And that is then to be seen as a requirement for the pre-phase A or the phase A study. Yeah, does that answer the question? And the number of studies we can do is, of course, unknown, But for sure, there will be a budget line, simply speaking, in the next program for these particular developments.
So this budget line will be in the next ministerial.
Yes. Yeah. Good. Anyone else?
Perhaps a question for you, Wim, because we had a question in the morning about archiving of samples. Because I think, I mean, I think it was a very relevant question, because there's a lot of efforts already done on the data, right? The infrastructure. How are we going to archive the data over time, over decades, when people graduate, when people retire, unfortunately when they pass away. But I don't know that there is anything for the sample, archiving and creating, or I don't know how you call it, the sample afterwards. Would that be part of the recommendation that the facility definition team actually makes? Because that's something that we had overlooked. I think in our discussion that was raised in the morning, and that I think is extremely relevant and important. So
yes, indeed, and it's absolutely up to the definition team to include that as a recommendation, because this is kind of how you structured it. You have a recommendation on how the facility would look like, and then you have a couple of recommendations on let's say the preconditions that you should have to maximize and to optimally benefit from the research that can be done. And this is one of them, with a long-term perspective.
Wim, similar to this, exactly is same on the same thing. Say, for example, if you go to a synchrotron facility, all the data, raw data will be, and metadata will be stored there and archived after some time. So I know ESA may not have that kind of archiving facility or something, but any data created on this type of microgravity platform can be, at least we can separately think about the physical samples after the experiment. So that means after some time, there's after embargo, anyone can should be able to even access to these data.
Yeah, I guess that for the data, it's more straightforward than for the actual samples, of course. But for material science, indeed, if you look at MSL, you have, well, all of the sciences in your sample. And for other facilities, it's different. Yeah, then the question is indeed who should be the long-term owner of the sample. For now, it was always the case that the samples are provided by the scientists and are returned to the scientists. Yeah.
I say maybe at the very least we should find a way to track the sample, to know where they are and who had them, because maybe sometimes it's true. I like to have the sample close to my office. I say I want to if I have the characterization device, if I need maybe 1 week to get the sample, it might take some time. But at the very least, we should have a way to track the sample. I don't know if such a thing already exists.
Yeah.
Because maybe the PI has the sample, but it will be distributed, and where is it after that?
Yeah, this is if you look at the latest version of our previous ESR document, it's now called ARD. There is a section that says that the scientist has to keep a data blank book. Well, no one knows what it is. This is what it is. It is
Okay.
that you indeed know where the data and where the samples physically are.
So there should be a contact that is available and updated regularly.
Yeah, indeed. Yeah. So yeah, the thoughts are in that direction, but yeah, we have to see how it will work. Yeah, especially for long-term preservation of samples, you also have to define the conditions under which. Yeah, and All right. Any more thoughts? Maybe not. That's fine. For the people joining online, unfortunately, there's no way to speak up. But feel absolutely free to drop me an email if you have any comment, suggestion, or question on this topic. The idea is to finish this report for the facility definition team in the coming weeks. And any suggestions like the one made by Sonia are definitely worthwhile to maintain and to capture in that report. So yeah, and if there are no further questions, I think it's not making much sense to keep you longer, and we can move on to the next point on the agenda, I guess. At least we will reconvene tomorrow morning at 9. For the facility definition team, we have to have a meeting as well at some point. We still have to decide, and maybe we can do that over dinner this evening, right? Yeah, with that, it's I guess time to conclude. Thanks for your contributions, and well, this was short, but good.
Thank you, Wim.